Today we will focus on 8E or 10F for HR students. We need to look at how to find the trig ratios for those angles, which are the multiples of pi over 6 and pi over 4. It is very important to know how to find the trig ratios of all special angles. Those special angles are the multiples of pi over 6 and pi over 4. If you have the angles, which are the multiples of pi over 6 and pi over 4, terminate on the axes, those angles are called axis angles. And the trig ratios of those axis angles have already been introduced in HC. So if you want to go over those knowledge in HC, that would be helpful for you to learn the trig ratios of those special quadrant angles today. Let's look at the two important special triangles. The first one is 30, 60, 90 right triangle. Or we can say it's pi over 6, pi over 3, pi over 2 right triangle. Let's look at this right triangle. The smallest angle should be 30 degrees or pi over 6. The middle angle is 60 degrees or pi over 3. And the largest angle is 90 degrees or pi over 2. This special right triangle is a half of an equilateral triangle. Based on this property, I can know this side is a half of this side. And this side is equal to its hypotenuse. So this side is always a half of the hypotenuse. And this green side opposites 30 degrees. And this side opposites the smallest angle is the shortest side. And the shortest side, we always let this one be 1. Since this side is a half of the hypotenuse, then the hypotenuse can be 2. Based on the Pythagoras theorem, I can find this side. It's 2 square minus 1 square and a square root. The result, it's square root of 3. Then we only need to apply SOHCAHTOA that we learned in Math 10. We look at this right triangle. Sine pi over 6 equals opposite over hypotenuse. It's 1 over 2. Cosine pi over 6 is adjacent over hypotenuse, root 3 over 2. Tangent pi over 6 is opposite over adjacent, 1 over root 3. For HR students, you also need to know how to find the other 3 trig ratios of pi over 6, like cosecant pi over 6, secant pi over 6, cotangent pi over 6. Based on the trig definition we introduced in HC, you should know this one, cosecant pi over 6 should be r over y. So we only need to flip the ratio of sine pi over 6. So this one is 2 over 1, which is the same as 2. Secant pi over 6 is r over x, should be 2 over root 3. Cotangent pi over 6 should be x over y. So I flip the ratio of tangent pi over 6, it's root 3 over 1, which is the same as root 3. In the same right triangle, we also can find the trig ratios of pi over 3. Sine pi over 3 should be opposite over hypotenuse. It's root 3 over 2. Cosine pi over 3 should be 1 over 2. Tangent pi over 3 should be root 3 over 1. We can just put on root 3. HR students also need to know the other 3 trig ratios for pi over 3. Cosecant pi over 3 is the reciprocal of sine pi over 3. So it's 2 over root 3. Secant pi over 3 should be 2. Cotangent pi over 3 should be 1 over root 3. The second right triangle is 45, 45, 90 degrees right triangle. Or we can say pi over 4, pi over 4, pi over 2 right triangle. This is an isosceles right triangle. This angle is pi over 4, and this angle is pi over 4. Two sides opposite these two angles must be equal as well. So these two sides are equal. Therefore, we can let this side be 1, and this side is also 1. Based on the Pythagoras theorem, I can find the hypotenuse, which is root 2. Using SOHCAHTOA, I can find sine pi over 4. It's 1 over root 2. Cosine pi over 4, 1 over root 2. Tangent pi over 4, 1 over 1, which is equal to 1. For HL students, let's also find a cosecant, secant, and cotangent pi over 4. Cosecant pi over 4 should be reciprocal of this ratio, root 2. Secant pi over 4 should be the reciprocal of this one, root 2. Cotangent pi over 4 is the reciprocal of this one, it's still 1. In section 2, I need to find the coordinates of the points on the unit circle for all those angles, which are the multiples of pi over 6, pi over 4, and pi over 2. First, let's label all the angles for those special multiple angles in one least positive rotation, which means I only look at the principal special angles. Starting from here, this is 0. This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. 2 pi over 3. 3 pi over 4. 5 pi over 6. This is pi, half rotation. Then 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 270 degrees. Then 5 pi over 3, 7 pi over 4, 11 pi over 6. Finish one rotation, go back to the positive x-axis. This one is 2 pi. So 2 pi is coterminal with angle 0. Right now, our task is to look for the coordinates of the point of intersection between each angle and the unit circle. That means we need to find the coordinates of this one, this point, this point, this point, all those points of intersection. How can we find the coordinates of those points? Let's take pi over 6 as an example. How can we find the coordinates of this point? On the terminal arm of pi over 6. Let's recall what we learned in 8C. In the unit circle definition, we introduced this one. The coordinates can be x and y, but after I applied the definition for the trig ratio sine theta equals y over r, and r equals 1, therefore y is the same as sine theta. So the y coordinate is just sine theta. Likewise, I can find the x coordinate. The x coordinate equals cosine theta. So the coordinates of this point is just cosine pi over 6 and sine pi over 6. Based on section 1, we have already derived what a cosine pi over 6 is, what a sine pi over 6 is. So cosine pi over 6 is root 3 over 2. Sine pi over 6 is 1 over 2. We can use the same method to find the coordinates of this point. On the terminal r, pi over 4, we should have the coordinates cosine pi over 4, sine pi over 4. Let's look at section 1. Cosine pi over 4 is 1 over root 2. Sine pi over 4 is 1 over root 2 as well. Let's find the coordinates of this point on the terminal arm of pi over 3. So this coordinates should be cosine pi over 3, sine pi over 3. Cosine pi over 3 is 1/2. Sine pi over 3 is root 3 over 2. So they are the coordinates of this point for pi over 3. And the coordinates of this point on pi over 2 should be 0, 1. How can we find the coordinates of this point of intersection on 2 pi over 3? Since 2 pi over 3 and pi over 3, these two angles, they have the same reference angle. And these two angles also demonstrate a refraction over the y-axis. Therefore, I can write up the coordinates of this angle easily. Since this is a refraction of this point over y-axis, I only need to opposite the x-coordinate value and keep y-coordinate the same. Therefore, the coordinates of this point is negative 1/2 root 3 over 2. The same idea can be applied to find the coordinates of 3 pi over 4. So this one should be negative 1 over root 2, 1 over root 2. And this one should be negative root 3 over 2, 1/2. And this one, pi, on the unit circle, the coordinates of this point should be negative 1, 0. Let's find the coordinates after pi. What are the coordinates of this point? Let's look at 7 pi over 6 and 5 pi over 6. These two angles have the same reference angle. That means this point is a refraction image of this point over the x-axis. Therefore, I keep the x-coordinate on 5 pi over 6 and opposite the y-coordinate. Likewise, I can find that this one should be negative 1 over root 2, negative 1 over root 2. And the coordinates of this point should be negative 1/2, negative root 3 over 2. 3 pi over 2, this point is a special one. So, but you also can think about this point is a refraction image of pi over 2 over the x-axis. So it's 0, negative 1. And those points are the refraction images of those points over the x-axis. Therefore, the coordinates of this point on 5 pi over 3 is 1/2 negative root 3 over 2. And this one should be 1 over root 2, negative 1 over root 2. And this one should be root 3 over 2, negative 1/2. The last point, let's go back to 2 pi, which is the same as 0. And this one should be 1, 0. That's how we can finish the coordinates of all those points on the unit circle for all those special angles between 0 and the 2 pi inclusive. Some students may feel it's a daunting job to remember the coordinates of so many points between 0 and the 2 pi. I do agree. If you want to remember all those points mechanically, that's really a daunting job. However, I try to retain those points in my mind through my pattern investigation. You will see, okay, I only need to know the coordinates of those points. The rest of the points are the refraction image of those points either over the x-axis or over the y-axis. So I only need to know the coordinates on 0, pi over 6, pi over 4, pi over 3, pi over 2. And look at the pattern for x-coordinates. So x-coordinate, starting from 0 all the way to pi over 2, is decreasing. From 1, then root 3 over 2, 1 over root 2, 1/2 to 0. The y-coordinate, instead, is increasing, starting from 0 to 1/2, 1 over root 2, root 3 over 2, to 1. Please try to use the patterns to help you remember those points with their coordinates in your mind. Let's look at the first example. Find the exact values of sine alpha, cosine alpha, and the tangent alpha for alpha equals 3 pi over 4. Anyways, I need to find sine 3 pi over 4, cosine 3 pi over 4, tangent 3 pi over 4. 3 pi over 4 is a special angle. So right now we need to learn how to find the trig ratios of any special angle between 0 and 2 pi. In section 1, we have already learned how to find the trig ratios of special acute angles like pi over 6, pi over 4, and pi over 3. And this time we need to extend the angles from the first quadrant to quadrant 2, quadrant 3, and quadrant 4. Let's look at 3 pi over 4. There are two different methods. The first method is to use the general definition. The second method is based on the unit circle we did in section 2. Let's introduce the methods one by one. The first method. What should we do in the first method? Let's sketch this special angle in the coordinate system first. 3 pi over 4. It's the second quadrant angle. Find its reference angle. What is its reference angle? Pi minus 3 pi over 4. It's pi over 4. Then I use this reference angle to form a right triangle. With this right triangle, I need to use the knowledge I learned in section 1. This right triangle is 45, 45, 90 degree right triangle. So I will let the sides be 1, 1, root 2. Since this right triangle is in the second quadrant, and this side should be negative on the negative x-axis, so I let this one be negative 1. Therefore, sine 3 pi over 4 is opposite over hypotenuse with the reference angle. So I only need to look at the reference angle rather than look at 3 pi over 4. So it's 1 over root 2. Cosine 3 pi over 4 is adjacent over hypotenuse with the reference angle. So it's negative 1 over root 2. Tangent 3 pi over 4 is y over x, or opposite over adjacent. So the y, the opposite, is 1. And the adjacent is negative 1. So it's 1 over negative 1, which is negative 1. The HO students, you can flip those three trig ratios to get cosecant 3 pi over 4, secant 3 pi over 4, cotangent 3 pi over 4 yourself. Right now, let's look at how we can apply the unit circle in method 2 to find a sine, cosine, tangent of 3 pi over 4. So the first step is the same as method 1. We still need to sketch 3 pi over 4, this angle, in the coordinate system. So 3 pi over 4 is here. So this time, we look at section 2. Write the coordinates for this point on the terminal arm of 3 pi over 4 and on the unit circle as well. So you go back to look at section 2. The coordinates of this point should be negative 1 over root 2 and 1 over root 2. And therefore, sine 3 pi over 4 equals the y coordinate, 1 over root 2. Cosine 3 pi over 4 equals the x coordinate, is negative 1 over root 2. And tangent 3 pi over 4 equals y over x. This y over this x, so 1 over root 2 over negative 1 over root 2, it's negative 1. You can get to the same trig ratios as method 1. But for me, I personally prefer to use method 1 rather than method 2 because I don't want to memorize so many coordinates for all those different points on the unit circle. I will continue to apply method 1 rather than method 2 to solve the problems in example 2 and example 3. Let's find the exact values of sine, cosine, and the tangent of 5 pi over 3. So this time we need to find the three primary trig ratios of 5 pi over 3. 5 pi over 3 is a special angle as well, and this angle is in the fourth quadrant. Let's sketch this angle first. So 5 pi over 3 equals 300 degrees. Second step, let's find its reference angle. The reference angle for 5 pi over 3 should be 2 pi minus 5 pi over 3 is pi over 3. Then I use this reference angle to form a right triangle. So this is the right triangle I can generate with this reference angle. Let's look at the angle measures in this right triangle. This one should be pi over 6, pi over 3, pi over 2 right triangle. It's a 30, 60, 90 right triangle. Based on section 1, I can label the side lengths of this right triangle. The shortest side, which opposite pi over 6, should be 1, hypotenuse is 2, and this side is root 3. However, this right triangle is below the x-axis, so this y value should be negative. So this side is negative. I put a negative for this side. What is sine 5 pi over 3? I only need to look at its reference angle. Sine reference should be opposite over hypotenuse. So sine 5 pi over 3 is negative root 3 over 2. Cosine 5 pi over 3, I only look at its reference angle for SOHCAHTOA, so it's adjacent over hypotenuse. It's 1 over 2. The same for this tangent. This tangent equals opposite over adjacent. So it's negative root 3 over 1, which is negative root 3. Example 3, without using a calculator, evaluate 4 sine 4 pi over 3, cosine 5 pi over 6. So in this product, I need to find two trig ratios. And both of the trig ratios are combined with a special angle. 4 pi over 3 is a special angle, 5 pi over 6 is a special angle. As long as we need to find the trig ratios of a special angle, DP expects us not to use the calculator. So how we can find sine 4 pi over 3 and cosine 5 pi over 6 respectively? So we follow method 1 that we introduced in example 1. So first we need to sketch this angle 4 pi over 3. It's in the third quadrant. Its corresponding reference angle is pi over 3. Use this reference angle to form a right triangle. So this right triangle should be 30, 60, 90 right triangle. Label the side lengths of this right triangle. We should have 1 here, 2 here, root 3. Since this right triangle is below the x-axis, so this one should be negative, this one should be negative. Sine 4 pi over 3. I only need to look at its reference angle. Sine reference angle equals opposite over hypotenuse. So it's negative root 3 over 2. Right now, let's find cosine 5 pi over 6. The first step is to sketch 5 pi over 6. 5 pi over 6 terminates in quadrant 2. Its reference angle should be pi over 6. Let's use this reference angle to form a right triangle. This right triangle is 30 degrees, 60 degrees, 90 degrees here. Right triangle. Label the side length of this right triangle. This one should be side 1, hypotenuse is 2. The middle side, which opposites pi over 3, is root 3. And this side is on the negative x-axis, so this one should be negative. So cosine 5 pi over 6, I only need to look at its reference angle. Cosine reference angle equals adjacent over hypotenuse, should be negative root 3 over 2. Therefore, this product is 4 times sine 4 pi over 3 is negative root 3 over 2. Let's plug in negative root 3 over 2. And cosine 5 pi over 6 is negative root 3 over 2. Let's plug this one in as well. 2 and 2 with this 4 can be cancelled out. So I only have negative root 3 times negative root 3 equals 3. So the result is just 3. You can find a lot of practice questions similar to this one in your homework. Try to use those questions to help you get familiar with the trig ratios of any special angle. Right now, let's look at the last example in this lesson. Example 4. Find all angles between 0 and 2 pi inclusive with a cosine of 1/2. That means I need to look for the angles. Okay, this angle can have cosine theta equals 1/2. This question is the same as example 4 and example 5 in 8D. Working backwards, we are given the trig ratio, we need to look for the angles. However, in this example, if you look at this ratio for cosine value or sine value, which is 1/2, this one means you cannot use the calculator. For me, I will realize from this ratio value that this angle must be a special angle. So therefore, you cannot use the calculator to find the possible solutions for this angle theta. Then how can we find this angle theta? We follow 3 steps that we summarized in 8D. The first step, let's look at this cosine ratio to determine the possible quadrants. Cosine is positive. Therefore, this angle can be in quadrant 1 or quadrant 4. Step 2, find its reference angle. The reference angle for quadrant 1 is this one. The reference angle for quadrant 4 is this one. These two reference angles must be the same. I only need to find one of them. How can I find the reference angle for this quadrant angle? Since this cosine ratio is 1/2, I need to think about both of these two special right triangles and think about in which special right triangle I can have adjacent over hypotenuse is 1/2. So 30, 60, 90, I should have the side lengths 1, 2 root 3. And the other right triangle is 45, 45, 90 right triangle. I should have 1, 1 root 2. So if you want 1/2, it only can occur in this right triangle rather than this one. So this right triangle is not gonna work for this cosine theta equals 1/2. So what is the reference angle? You want adjacent over the hypotenuse. So the reference angle is 60 degrees. After I find out the reference angle, I can find the quadrant angles based on the reference angle. So quadrant 1 angle is the same as reference angle, 60 degrees. Quadrant 4 angle, this rotation angle should be 360 degrees minus 60, which is 300 degrees. Of course, if you can write down the radians for the reference angle and the rotation angles in quadrant 1 and quadrant 4, that will be perfect. Here are the homework questions for this lesson. Before you start to do your homework, I want to encourage you to finish the table in 8A. There's a table that we did not finish in 8A. We only finished the first column, in which we change all the degrees to radians for those special angles. However, we did not finish sine, cosine, tangent, cosecant, secant, and cotangent for those special angles between 0 and 360 degrees. So right now, I want you to finish this table. SL students only need to finish the trig ratios for sine, cosine, tangent. But HL students need to finish all 6 trig ratios for every single special angle in this table. Through this table, I also want you really practice the skills of how to find the trig ratios of a special angle by either using method 1 or method 2. If you feel method 2, which is the unit circle method, also makes sense to you and you like this method, feel free to use the unit circle method as well. The trig ratios of axis angles can be reviewed in 8C. The trig ratios of special quadrant angles have been introduced in 8E. This is the end of this lesson.